This video is going to go over how you would do a 4-axis program by bringing in a wireframe geometry file, DXF file, instead of a parasolid file. So first step is I'm going to import a file. You should have already gone through all the previous tutorials and know these steps already for these beginning steps. So we're going to import our 2-axis file. Preview, let me just check. Yep, it's just a simple square with a taper on one wall. So what we have here this was created, what you want to do when you create your file and make the DXF file, you want equal elements on the bottom and top. So I'll just show you that here. We'll go into 2D drawing and we can turn on 2D drawing, and you can just hover with the mouse around the geometry and you can see there's like an element here at the top and an element here at the bottom. There's vertical match lines at the start of each element and at the end of each element. So there's an arc here that's matched to this arc here. So we need equal elements. Now if we look at these arcs, this circle here, this is like an elliptical circle or arc. This is actually 1, 2, 3, 4 elements, and same thing on the top. 1, 2, 3, 4. Now each line is not drawn in. The match for this element here is not drawn in, which is okay. The system doesn't require every match line to be drawn in. It'll know that you want to go sequentially through each element matched top to bottom. Let me get out of my 2D drawing with the blue button here. So now we go to feature recognition, contour extraction, and take note, table of programs already filled in. That's this top geometry. So your reference is at the top. That's your program plane. And the table of next is 0. That's not too important for this step, but when you go and do machining path, that's going to be important, because if you're going to have what the system does is it puts a tab at the end of the cut and it has to retract off of the face a small distance. So we need to know which surface we're referencing from, so that when we enter in that distance, it's going to come from the table of program or table of next. If you want to reverse this, we can say push in this button here and say it's the bottom. Just pick any element and it'll go to 0, and I can click this arrow here and put it at the top, click an element at the top. So now it's 0 and 3. So the program plane will be on the bottom here now. So if I told it to retract off this bottom face a little bit, the top move will be a longer move. Anyway, we're going to select die, click on something here. If you want to do a start element, doesn't really matter. If you have more geometry on there, if you select one first, it'll only find this one shape. So now we see, once we do the contour extraction, we see all the match lines that the system found automatically. So that's what you want. You want to have all the match lines and everything looks correct. It's not out of sequence top to bottom. If it doesn't work, then you could have an unequal number of elements. So we need to have equal number of elements. So that's this example. Let me save it as number 1 here. All right, now we're going to do the second example. This file new, model. It's a little bit more complicated. I've got 2 of the same file here, basically. One has my initials in it, so we'll go with this one. And now I've got a DXF file, and let's go into 2D drawing. And we can see we have elements broken up here to match these elements, but there's no match lines. If I put it in 3D, it's flat. This circle is actually on Z0. What needs to happen at this point is we need to have this circle raised up in the air for the height of the part, and we should also have the match lines drawn in for top to bottom, for where the end of each element matches to the other shape. So there's a procedure to, if you wanted to do that and raise that up, you can do that in the software here. But to speed this video up a little bit, I'm going to just open up another model where I've already done some of that work. So let me do a file new, and let me go model, 2D file insert. Let me pick mine. Oops. I've already raised the geometry up. So if I hit it in 3D, see the circles up in the air? There's a way to do that in IQ, but I want to skip over that because I want to just go through the basic concepts of doing this. 2D drawing, I need a match line. I'm going to go into 2D drawing. Top view. So I've got these elements here. Now, the selection color is important because if I pick something here just to light it up, you can't tell. The selecting color right now is green. And if you have this situation where you select something and it's not changing colors, go into settings, display, slide the slider down, selected element. See, it's green. That's the same color as this shape. So I'm going to change color on that one to be red. So if I select it, see, it'll change. Like if I turn on cut or whatever and I click it, it'll be that color now. So I can tell where everything is. Okay, so let's zoom up. We're going to add a match line from here to this arc here. Right? So remember, over in this area here is where the end line is. And remember, over here is where it is. You may have to put your finger or something on the screen to remind yourself so you can find it. This is a little bit tricky. We're going to turn on match line, this top choice here, match line. Now we get these yellow markers. Ignore the yellow markers. We're looking for the red dot. So I want to match the end of this element with the red dot to the red dot on this arc. Got to find where that end element was. I'm just slowly rolling the pointer on the geometry till I find where that end point was. I forgot to put my finger up on the screen to find it. There it is. Boom. All right, got the red dot. I'm going to click. Now the other match line is at this end point here, and it was over here somewhere. There. Okay. I only really need one of them, but I put two in there just because I happen to have it zoomed up to show you twice. 3D view, you see it draws in a match line top to bottom. You only need one. Hit the blue button to get off of this screen. Oh, let's go back in and get rid of geometry I don't need. 2D drawing, top view, cut, grab this stuff down here, I don't need it, confirm, cut, grab these line elements here, click, 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 confirm, blue button. Okay, now here's my shape. I need a start hole, 2D drawing, starting hole, put it here, new, close. So I have my starting hole. Okay, feature recognition, contour extraction. Already got my table of program, which means that the table of program plane is up here at the top, and the table of next is down here. So this, when I do the toolpath, this is important to recognize this is your program plane that the system is reading to reference when you do your tab. We're going to say die. I don't have anything else, so I can just hit extract. And now you see all the match lines show up. Let's put it in a top view. See, these are the two I drew in, and the system just went sequentially around element to element, matching the rest of them up for you automatically. So you don't have to have all of them. You just simply need to have one to get it to start so it knows to sequentially where to start from. So if you drew your geometry correct, it should find everything. It should find them all sequentially. Okay, so that's how you do the feature recognition. I got an extra contour here for that circle, which I don't need, so I'm going to delete it. So I just have the one contour. I'm not cutting a hole in this piece. That was the start hole, that piece of geometry that it found as a hole. Okay, so the concept here is at this point is you need to have equal elements top and bottom, and at least one match line. You can have all of them, but you need at least one. And also the concept of table to program, which surface, the top or bottom, is your reference for the tab. Okay, so now we're going to go on to, let me file save this, as I'm going to call it number 2. We're going to go back to number 1 and do the machining. Okay, let me go file new, get rid of this, file open. I'm going to go back to my number 1 program because the shape is a little simpler and I can explain what happens here a little simpler. Let me put my starting hole in and let me look at the Y. I'm just hovering with the mouse to give me a Y number. I need X0 and Y 3.5 or something like that. I'm just throwing one in here. Okay, I don't know that it's exactly in center. I just threw one in there for now. Now we're going to go machining path, path generation. Here's our contour. We're going to say generate path. You should already know what all this stuff is for. You got your cutting conditions here. What we're going to talk about specifically, what we're looking at in this example is your residual stock and your avoidance. This is a little trickier on a 4-axis shape because the wire is tilted. If I approach on this flat face here, it looks just like a regular 2-axis program. So I got my residual is the stop. Let's bump that up so we can see it a little easier, 50. And the avoidance, this is the distance it's going to pull back. So let me say okay to that. And let me top view it. And it says specify the starting hole. I'm going to pick that starting hole. Specify the entry element. I'm going to specify this flat down here. And everything looks normal and you made a program. Good. It's perfect. Here's your little tab. 50 thou back and 100 thousandths retreat to cancel it. So what actually happens, the machine doesn't, if you're only cutting one shape, it doesn't really do this little release move. You may have recognized that fact by now or not, I'm not sure. When you do multi, if I was going to cut 3 of these or 2 of these or more, that's going to be the hold on tab after the roughen, and it cuts the wire and it moves to the next one. And this release move is what we're concerned about, that it releases far enough into the slug, tilting the wire back vertical that it doesn't cut into the shape. So let me explain what I'm talking about for that. Let me get rid of this. And we're going to do it a little bit differently this time. We're going to pick the tapered wall. So we're going to go machining, path generation, same stuff. I'm going to keep my numbers all the same and say okay. Pick the start hole and pick this other wall. Okay. Here was the little release move. See, look at how far on the top it has to move back. My reference plane was the bottom. And so it moved back that 100 thousandths back in while the wire was straightening up. So it's doing a little 50 thou move on the bottom, and it's doing this, looks like about an inch long move, but the reference was the bottom on this case when we do the feature recognition, right? So let's go check this one more time. Let me delete the path. Feature recognition, contour extraction. So let's do this again. Let me just delete the contour. Yes. And machining path, path generation. Residual stock. Whoops, picked the wrong starting hole. Now, see, now I got the path of the slaver plane. Escape is interferential with, do you want to continue? So this means the path of the table of next, slaver plane, that escape move, that's the little tab where it's going to escape, is interference with the table of program plane. because it's now at the top. The table of programs up at the top, it backs off 100, and you're going to see what happens. I'm going to just say yes. See the little move here? So that's the top was the reference, and it did the 100,000s, but while it's straightening up, it's got to cut the bottom, and that's going to gouge into the piece. So it gives you an alarm you're doing that because we didn't give it a big enough release move. So now the top is the reference. I have to give it that big 1-inch move now. So let me show you how you can fix it. You can either redo the draft or the feature recognition, or you can go into machining path, path correction. Let's make this a big move. I'm not sure what the number is supposed to be, but let's say 1.2 starter hole. Still not enough. I got to go even more than that. Let's correct it again. Two-inch. Okay. So this is like a 2-inch move at the top to the little, what you get at the bottom, what I'm not sure how big it is at the bottom. It's 2 inches off the top because the top is the reference now. So that's, we got to make sure, and I didn't get that alarm. So that's what I'm saying. You got to watch this when you get that error message. All right, so let's go into our more and that's ready to go. You just go, NC conversion, convert to NC. So that program's done. So let's go to our more difficult file. Okay, so here's this one. Go top view, 3D. So what I want to do is come in, top view again. I want to come in this face here. Let me tip it a little bit. Okay, feature recognition, contour extraction. So what I want to do is pick the smaller sized part as my reference. And I've got it the other way around right now, see? So let's keep that in mind. I should have done it the smaller size as the reference. So, but anyway, so it's the other way around. The top table of program is way up here like that bad one I showed earlier. And then we're going to go machining path, path generation. And we're going to keep our numbers this avoidance pretty big because I know it's going to have to be a pretty big number. We're going to pick our start point, pick our approach element, top view it. We didn't get that interferal message alarm. So I got a big enough retract move. So here it is here. From the top coming way back and the bottom coming. It's way bigger than I really need. So let's go adjust it a little bit. So let's go path correction. Let's bring it down to 1 inch and we'll probably get that message. See, this labor plane is interferential or whatever. Say, okay. So now we're going to see where we got the problem. So this is where you get the problem. It really isn't a problem, but it's telling you that. So see this little move here at the bottom? Looks like it does it the wrong direction. So it released here, but the bottom cuts into the part. So that's your error message, your problem with that one. So we want to watch out. Actually, if you're doing one part, it'll be okay. You can just make the code, and I'm pretty sure what's going to show you, the machine just stops here and then it keeps going. It doesn't do this little move. It actually keeps going, and then it goes back to zeros or your start hole. It doesn't actually do this move, but if you're doing multi, it will. So I'm just explaining this, so in case you use multi, you got to watch for this. So we're going to go machining path, path correction. My avoidance was 100. Let's set it at 1 inch. Start hole, approach face, still a problem, but it's getting better. It's getting closer. So you just keep putting that number until it brings it back into this shape. Keep adjusting it. But the better way to do this would be let's delete the path. Let's delete the feature. So the way to do this, so here's my back to my geometry, is feature recognition, contour extraction, put the table of program on the bottom. Let's put this one in at the top. Click on that, put that at the bottom. Okay, so now I've got them reversed. It's the same thing it looks like, but the reference plane is TP is on 0 now, the smaller shape. Pick the smaller shape for your reference plane, and everything works a lot simpler. We'll go to machining path, path generation. We want to do just our 2-axis die, or top bottom different die. Avoidance of 100,000, so probably work fine. Start hole, approach face. Oh, still doesn't work. Let me just see what we got. So the problem now is this pulls back and the top pulls back. Let me see if I can get this centered so you can see it. This line here is the pullback on the top shape, which is well into the slug. What it's telling you the problem is because it's perpendicular to the radius, it crosses over. It stops, and then this crosses over the lead-in line. This green one was your lead-in line, and this is the release line. They cross over, which it's okay. That's fine. So it works. You can see here somewhere here it crosses over because it's always perpendicular. The release move is always perpendicular. See, it's perpendicular down here. So to put that one perpendicular off of this shape, this is coming at some weird angle because of these match lines are tapered kind of from the bottom inward. So it gives you kind of a funny move at the top. So it'll be fine because it backs up far enough. Let me explain it a little bit better with a different length of the tab. Let's go path correction. Maybe you didn't quite understand what I was meaning. So we'll put a residual stock, your hold on tab, of like a 1/2 inch. So it'll be way back off of that shape. Shut that off. There's my start point. Didn't get the message, right? So let's see where we put it. It's way back over here, at a 1/2 inch back. Now I got it away from all this other geometry so that you can see what's going on. Here's your hold on tab of a 1/2 inch, but the reference plane on the bottom is your 1/2 inch distance. And let's tip it a little bit so we can see what's going on. Oop, wrong one. Tip it a little bit. Okay. Shut that out. Here's your release move right here. And there's the match line to the top. Here's the release line off the top geometry. It's going way back over here, which is fine. That's what you need it to do. If we put it back in a normal orientation, you can, let's do a top view. You can't really see exactly what's going on. Just tip it a little bit and you can see what's going on. So I just wanted to point out what's happening here with that tab on this geometry. So either case will work for you. You can either leave a big tab on there. Just make sure it doesn't cut into the shape like we saw in the first time I did it. You want to make sure it releases inward on both the top and the bottom. That's the main point. And you have to adjust. You might have to adjust that those numbers over here. Let me delete path correction is what I want. These numbers over here, the residual stock or the avoidance, you might have to raise that up more on a 4-axis one than what you think you should.